Hey there, we're back and we're going to talk about slope and how slope really plays into linear equations. So let's first talk about some of these formulas you need to know. And by know, I mean know. No, not like you've got a note card. No, not like you've got it in your notes somewhere, but no, like no. You can just draw on them from your memory. Okay, so a lot of these you already know. What is the slope of a line between 2 points? Well, if I have 2 points, x1, y1, and x2, y2, so 2 coordinates, I can find the slope of the line that goes between them by taking the difference of the y's, y2 minus y1, and dividing that by the difference of the x's, x2 minus x1. Okay, that's a pretty easy thing to do. So let's go ahead and apply that here. And we'll come back and fill this in later. All right, so I've got 2 points here, -3, 4, and -4, -2. So I want to calculate the slope of the line that passes through those 2 points. So I can choose this to be my first point or this. I'm going to choose this to be my first point and this to be my second point. So I take y2 minus y1, -2 minus 4, and I divide that by x2 minus x1, -4 minus -3. Okay, so I'm going to simplify this a little bit. -2 minus 4, -6, -4 minus -3, that becomes plus, so over -1, and so we end up with a slope of +6. Okay, let's do these other points. Okay, 5 minus -1, and -1 minus 4. Okay, so I've got 5 minus -1, that'd be 5 plus 1, otherwise known as 6, and -1 minus 4 is -5. So my answer here is -6/5. All right, now I have a set of 2 points, -3 minus -3. Actually, we can go here to here. So -3 minus -3, all divided by -2 minus 5. -2 minus 5. All right, so -3 minus -3, the number minus itself is 0. And -2 minus 5 is -7. Whenever you have a 0 in the numerator, you end up with a result of 0. Okay, now let's finish this one. 7 minus -1. 7 minus -1. Divided by 12 minus 12. 12 minus 12. 7 minus -1 is 7 plus 1. 8 over 0. Oh, when we have a 0 on the bottom, we call that an undefined slope. Okay, so let's talk about these slopes for a second. If I have a slope of 6, this really means that for every point on the line, to get to another point, I would rise 6 and run 1, because remember, 6 can be written as 6 over 1. Okay, so if I'm rising 6 and running 1, you have a line that is going up from left to right, or it is increasing. Oh, and I think my math lab calls it rising or falling, or so in this case you would say rising. Okay, now let's think about this one. If I have a set of points where the slope is -6/5, that means to get from one to another, I'm going down 6 and over 5. So it'd be something like this. So down 6 and right 5. And remember that you can't have a -6 and a -5 here if you want this to be negative, because that would end up being something positive. But I'm going down 6 and right 5. So what is happening with the slope of my line here? It's decreasing, or in other words, it's falling from left to right. Okay, here we have a slope of 0. I am not rising at all, but I'm definitely running. I'm not rising at all, but I'm running. So you have something like this. And what you have here is a horizontal line. Okay, notice that you have the same y values here. Yes, we're at the same level on the y. Okay, and over here, we have a rise of 8, but no run. So from here to here, we're rising 8, but not running at all. So what we have here is a vertical line. And you can always identify a vertical line because the x's are the same. Okay, so let's come back up here and talk about these other things that you need to know. You know this, I believe. Slope-intercept form of a line is y equals mx plus b. And recall that m represents your slope and b represents your y-intercept, or the point at which your line crosses the y-axis. Point slope form of a line is y minus y1 is equal to m times x minus x1. Okay, and in this case, it's called point slope of a line, or form of a line, because this represents some point on the line, and it can be any point on the line. And then, of course, m is going to be your slope. So point and slope. Okay, and this is not usually emphasized in high school, mainly because there's an infinite number of point slope forms of lines. Whereas for a slope-intercept form of a line, there's only one, so it's easier to kind of generalize there. General form of a line is used not so much at this level, but usually in higher level math courses. Ax plus by plus c is equal to 0. Some textbooks push that c to the other side of the equal sign and make it ax plus by is equal to c. Either way is fine. Okay, now a vertical line and a horizontal line. We said vertical lines have the same x values, right? All of the x values on a vertical line are the same. And so actually the vertical line will be in this form, x equals whatever that number is. X equals c. In this case, it would be x equals 12. Easy peasy. All right. A horizontal line has the same y value. So the horizontal line is in the form y equals c. Okay? Y equals what here? Well, our y's are both -3, so this line is going to be y equals -3. That's easy. And then the last formula you need to know is your average rate of change formula. This is the same as the slope formula when you're dealing with linear equations. When you're not dealing with something linear, it's just your function values, and it's really the slope of the line through the 2 points, but you may not be dealing with just a linear function. So we say that the average rate of change, or the AROC, is equal to f of x2 minus f of x1, all divided by x2 minus x1. Okay. And those are your formulas you need to know. Okay, so we're going to pick it up with a couple of examples of what can you do with lines. And there's so many things we can do. One of the things that you're going to be asked to do is give the equation of a line if you've been given 2 points. So anytime you are asked to find the equation of a line, you're going to need 2 things. Definitely need slope. And then you also need the coordinate of at least 1 point that that line is passing through. You can have lots of lines with the same slope, but unless you've got a point to anchor that line down somewhere, then you have no idea where that line is. So you definitely need a slope and at least 1 point. Okay, and so in this example here, we're going to find the equation of a line that passes through the point 2, -5, and -3, 5. Okay, so what do you notice right away that we don't have? We don't have slope, but we just talked about how to find slope if you're given 2 points. So let's do that. Let's take our 2 points, 2, -5, and -3, 5, and let's find the slope. Slope is going to be y2 minus y1, 5 minus -5, over -3 minus 2. Okay, so 5 minus -5, that's the same as 5 plus 5, right? And we have 10 over -5, also known as -2. So I know my slope is -2. Now, I need to use that slope with a point. Well, which point? It doesn't matter. That's one of the beauties of having more than 1 point. If we're asked to write it in point slope form, then it's a piece of cake. All I'm doing is plugging in the slope where the m goes, and then one of these points where the x1 and y1 go. So remember, point slope form looks like this. Y minus y1 is equal to m times x minus x1. All right, so let's plug in one of the points, and it doesn't matter which one. I'm going to choose the first one, and I'm going to plug in the x for x1, this y for y1, and this slope for m. And then I'm finished with that form. Y minus y1, -5, is equal to m, -2, times x minus x1, the 2. Okay, now all I've got to do here is make this minus thing go away, and I'm finished. Y plus 5 is equal to -2 times x minus 2. And this would be a point slope form of the line in question. Now the example also said write it in both point slope and slope intercept form. So to change this to slope intercept form, it's really easy. All we're going to do is we're going to distribute this -2 through, and then we're going to move this -5 to the other side using subtraction. And I'm going to move up here. So I had this, y plus 5 is equal to -2 times x minus 2. And what I said was we're going to distribute through, so let's do that. And I'm just going to say y equals, distribute through, -2x plus 4. And then I need to move this 5 to the other side, and when I do that, it changes signs, and because we're subtracting it, it becomes -5. Let's combine these into one term, and we're finished. Y is equal to -2x minus 1. So this is really saying that I have the 2 points that I have. If I drew the line through them, that line would have a slope of -2, and it would pass through the y-axis at the point -1. Okay, so that would be how you would approach a problem where you're given 2 points and need to find the equation of the line. The next problem that we're going to look at is write the equation for the line 3x plus 2y is equal to 10. Okay, and we're going to write it in slope-intercept form. When it says slope-intercept form, we are really just solving for y and putting the terms in the right place. So I want to put this 2y on one side of the equal sign, and I'm going to move this to the other side. And I can put it after the 10, but I know that my slope-intercept form is in the form y equals mx plus b, so I'm going to actually put it before the 10. Okay? Y is equal to -3x plus 10. And now I need to isolate my y, so I will divide everything through by 2. And I would have y is equal to -3/2 x plus 10 over 2, which is also known as 5. Okay. So I have solved for y. Now I want to graph this function. This is saying I want to graph the function that has a slope of -3/2 and has a y-intercept of 5. So I'm going to start with that y-intercept and plot it. Plot it here on your graph on the y-axis right at 5. Okay, now I'm going to use my slope. Down 3, right 2. 1, 2, 3, right 2. And I might do it again just because I love plotting points. Down 1, 2, 3, 1, 2. And you can kind of see the shape of a line taking form. You can do that as many times as you want, but you need at least 2 points, and then you can sketch your line. Okay, we're going to pick up in part 2 with some other cool things we can do with slope and equations of line.